Everything scientists thought, everything you thought, everything you were taught in school, it's all wrong. The edge of the solar system isn't what you think. There is something out there you won't believe. The journey begins with the Kuiper belt, a donut-shaped band of space filled with the frozen leftovers from the birth of our solar system. It starts just beyond Neptune's orbit at 30 astronomical units from the Sun, and it stretches outward to roughly 50 astronomical units. Think of the Kuiper belt like a giant cosmic junkyard, but way more interesting. Instead of old engine blocks and rusty hubcaps, this region is packed with ice-rich rocks, comets, and dwarf planets. It's kind of like the asteroid belt between Mars and Jupiter, but on a much larger scale and with more exotic space rocks. And there is a lot out there. So far, astronomers have cataloged more than 2,000 Kuiper belt objects, but that might be the tip of the iceberg. Models and observations suggest there could be hundreds of thousands of icy bodies larger than 62 miles in diameter hiding in this region, and possibly millions more smaller than that. Some of these objects are tiny specks, while others are surprisingly complex. But it's not just a pile of frozen debris. Our understanding of it has jumped forward thanks to daring space missions. Most famously, NASA's New Horizons spacecraft gave humanity its first up-close look at the Kuiper Belt world when it flew past Pluto and its moons in 2015. It revealed mountains of ice, complex geology, and even evidence of ancient atmospheres. And New Horizons didn't stop there. In 2019, it flew by a second Kuiper Belt object, Arakoth, located well beyond Pluto's orbit. This tiny double-lobed world with its two clumps stuck together is one of the most primordial and untouched objects ever explored by a spacecraft. The Kuiper Belt is a literal time capsule made up of leftover debris from the disk that built the Sun and every planet we know. Beyond the Kuiper Belt, the solar system doesn't end, it gets weirder. Past Pluto, past the Kuiper Belt, past the scattered disk, out here where the Sun is just another star, the astronomers believe there's a vast invisible frontier called the Oort Cloud, where our solar system finally begins to dissolve into deep space. The Oort Cloud isn't a flat ring like the Kuiper Belt. Instead, it's thought to be a giant spherical shell surrounding the entire solar system. Imagine a cosmic snow globe, but instead of glitter, it's filled with chunks of ice and rock that never quite made it into planets. So what is inside of this mysterious region of space? Astronomers think there may be billions, possibly trillions of icy objects in the Oort Cloud. These range from comet-like nuclei just a few miles across to potential dwarf planet-sized bodies that have never felt the warmth of the Sun. Nothing in the Oort Cloud has been directly observed yet. Objects are just too far away and too faint. But astronomers infer its existence from all the paths of long-period comets and from subtle gravitational effects on the objects we can observe. Some of the most spectacular comets likely come from this distant bubble. Comet Hale-Bopp lit up the sky in the late 90s, bright enough to see without a telescope. And Halley's Comet, the most famous of all, returns about once every 76 years. Halley might not come directly from the farthest Oort cloud, but its elongated orbit is exactly like the kind of fingerprint you'd expect from a comet born in the deep freeze beyond the planets. The Oort cloud's vast distance from our solar system means it is gravitationally fragile. Out there, the Sun's pull is barely stronger than the tugs from passing stars. These tiny nudges can knock objects loose and send them plunging inward on collision courses with planets in our own solar system, including Earth. This is one reason why scientists are scrambling to learn more about the Oort cloud. The next planet-destroying giant might already be lurking beyond the inner solar system. And it is here at the edge of the Oort cloud where things get really interesting. Because there is one more structure out there, not made of rock, not made of ice, but made of force. A vast invisible shield around the entire solar system, the heliosphere. This isn't a ring of rocks or ice like the Kuiper Belt. It's a bubble-like force field formed by the massive amount of energy and radiation the Sun produces. The heliosphere exists because the Sun continuously emits a stream of charged particles, also known as solar wind. Basically, these are gusts of plasma busting out in all directions at hundreds of miles a second. As this wind races outward, it pushes against the material between the stars and literally carves out a bubble in space created by the Sun's awesome power. This bubble shields the planets inside it, including the Earth, deflecting high-energy galactic cosmic rays and cutting down the radiation blasting through the galaxy. Without it, you and everyone else on this planet might not be here. But first, we want to thank the sponsor of today's video, Private Internet Access, aka PIA. the world's most trusted VPN provider, trusted by over 30 million users worldwide. Anytime you hop online, especially on public Wi-Fi, your device is sending data through networks you don't control. A VPN fixes that. PIA is hiding your IP address and encrypting your connection, so it's much harder for ISPs, network admins, government censors, or even hackers on the same network to snoop what you're doing. Their no-logs policy has been proven multiple times in court and verified by an independent audit conducted by Deloitte, one of the world's leading auditing firms. I love that I have PIA when I'm traveling, since you can switch your virtual location with servers in 91 countries and all 50 states, which means I can access region-restricted sites and streaming services and get around location-based limitations. That way I can always watch I Think You Should Leave on Netflix no matter where I am. PIA runs on Windows, Mac OS X, Linux, iOS, Android, and more. And one subscription covers unlimited devices, so you can protect everything you use. And right now, there's an exclusive offer just for you. Just go to piavpn.com/theinfographicshow, also in the description, to get 83% off private internet access, bringing it down to just $2.03 a month. Plus, you'll receive 4 extra months completely free. It's risk-free with a 30-day money-back guarantee, and 24/7 customer support is always available to help. So go try private internet access right now. Your privacy deserves no less, and with PIA, you're in good hands. First up is the termination shock, the spot where the solar wind, which has been streaming outward at supersonic speeds, abruptly slows down. It starts to feel resistance from gas and debris floating through interstellar space. Measurements from spacecraft have put this boundary roughly around 80 to 100 astronomical units from the Sun. It's hitting resistance and losing power. Just beyond the termination shock lies the heliosheath. This is a turbulent zone where the solar wind has slowed, becoming hotter, denser, and more compressed as it scrapes up against interstellar space. And this is where things stop being theoretical. We didn't just model this region or predict it on a chalkboard, we sent something through it. Voyager 1, Voyager 2, two machines launched in the 1970s, still flying decades later, still sending data back across billions of miles of empty space. And as Voyager approached the edge of the Sun's domain, the readings started to change, not dramatically, not all at once, but enough to make scientists take notice. The solar wind wasn't acting normal anymore. The pressure was rising. The particles were behaving differently. The magnetic field lines were tightening and twisting into strange shapes. Then the temperature jumped, and the turbulence spiked. It wasn't a solid object, it wasn't a planet, it wasn't even something you could see. Voyager was crossing into a boundary that wrapped around the entire solar system, a violent zone of compressed plasma, something so extreme that scientists didn't know what to call it at first. And then they landed on a name: the Wall of Fire. And it wasn't just hot, it was insanely hot. Hot enough that the numbers didn't sound real. The temperatures here reached between 30,000 and 50,000 Kelvin. Beyond the heliosheath, the solar system may leave a long, comet-like tail behind it as it cuts through the galaxy. And for years, scientists thought the front would form a bow shock, like water piling up in front of a speeding boat. The last part of the heliosphere is called the heliopause. This is the very outer edge of the heliosphere, where the solar wind gives way to interstellar space. It can be considered the ultimate boundary between the Sun's influence and interstellar space. Inside the bubble-like force field of the heliosphere, solar particles rule. But just beyond it lies the true frontier, where stars, cosmic rays, and the vast expanse of the Milky Way await. And it is here where one of the most intriguing mysteries of our solar system lies. So what exactly is a bow shock? In space science, it's the same basic idea as a boat. Fast-moving material slams into a medium it can't easily push aside, making gas and dust pile up, heat up, and then compress into a shockwave. On Earth, a bow shock forms in front of a fast-moving aircraft and can produce a sonic boom. In space, it can form where a massive object, like a planet or a star, plows into gas or particles. For decades, scientists expected our solar system to have one too. Our solar system's shockwave should have appeared just ahead of the heliosphere, where the solar wind collides with the gas and dust between the stars. This was thought to happen just beyond the heliopause. Earlier models estimated the bow shock might lie at roughly 230 astronomical units from the Sun, where there would be a dramatic boundary between the Sun's solar winds and the interstellar medium of the Milky Way. But when scientists looked closely, there was nothing there. Thanks to data from NASA's Interstellar Boundary Explorer, or IBEX, launched in 2008, scientists were able to obtain a much closer look at how our heliosphere interacts with interstellar space. And what IBEX found surprised scientists. There's no classic solar bow shock at the edge of our heliosphere. Instead, they found that the sun's motion through the galaxy isn't fast enough, and the surrounding magnetic field isn't strong enough to create a bow wave. Astronomers have seen these cosmic bow shocks occur from planets in our own solar system. According to the IBEX mission findings, the Sun and its heliosphere travel through the local interstellar cloud at about 52,000 miles per hour. That seems fast by everyday standards, but in space the interaction with the surrounding material isn't violent enough to create a true bow shock. Instead, the heliosphere forms a bow wave, a gentler buildup of particles and magnetic fields that piles up ahead of us without the dramatic snap of a shockwave. But this doesn't mean that bow shocks don't exist anywhere in space. Many other stars, especially those moving faster through denser interstellar gas, show bright, dramatic bow shock structures that astronomers can see in infrared and radio light waves. Our own Sun's environment just happens to be too calm and the local interstellar medium too magnetically active for a classic shock to develop. So there isn't a sudden blast front at the edge of our solar system, but a more subtle sweeping wave of compressed interstellar gas and magnetic field lines. And that's a clue not just about our own star's motion, but about the broader environment of the Milky Way itself. Instead of a fiery frontier, the boundary ahead of us is a transition zone, where the sun's energy field meets the rest of the galaxy. Regardless, the edge of our solar system is likely not what you learned in school. There is so much more to our solar system than 8 planets and a star. There are astronomical amounts of exotic space rocks, rogue dwarf planets, and comets. There is a wall of hydrogen, and there is a bubble force field that is protecting you and everything else in our solar system from the harsh environment of interstellar space. And thanks again to today's sponsor, Private Internet Access. Go to piavpn.com/theinfographicshow to get 83% off and take back control of your digital life. Now watch, you won't believe these insane planets that actually exist. Or check out this video instead.